Today we're going to talk about the first topic in Unit 6, which is Pythagorean Theorem. You should have already watched the video on simplifying roots, so let's use that information and dive in as we learn how to calculate Pythagorean Theorem. So Pythagorean Theorem is all about right triangles, okay? Just a quick reminder about what the right triangle looks like. A right triangle has a 90-degree angle, okay? So we have a 90-degree angle. And these two sides of the triangle, A and B, that form this 90-degree triangle, these are called the legs of the triangle. Leg and a leg, okay? They're the two that are perpendicular to each other. If I draw a diagonal line through the little box and up across, the one that is across from the 90-degree angle, the longest side, is always going to be the hypotenuse. Hypotenuse, okay? And the Pythagorean theorem is a theorem because it states that in any right triangle, the two legs squared will equal the hypotenuse squared. So a squared, one of the legs, plus b squared, the other leg, will equal the hypotenuse squared, okay? So both of these need to be a leg of the triangle, and it doesn't matter which leg they are. You can pick either of the shorter sides, and then the longest side, this one must be the hypotenuse. Has to be our hypotenuse, okay? Now this should be somewhat of a review for you. You should have seen the Pythagorean theorem before, but it may have been a while. Okay, so let's look at how we would set this up. We have a squared plus b squared equals c squared, right? I need a leg plus a leg is equal to the hypotenuse squared. Now, x, in this case, is the hypotenuse. Always start by identifying which one is your hypotenuse, because that's going to be c. This is our hypotenuse, that's going to be the c. The other two are going to be our a and our b. A, and it doesn't matter which, 5, and I'm going to square it, and 12, and that's going to be squared. Our hypotenuse is going to go on the other side of the equal sign. It's going to be c, and it's also squared. Okay, then we just simplify these two. 5 squared is 25, and 12 squared is 144, and that equals x squared. Okay, so then we add these together, and we get 169 is equal to x squared. But this isn't done yet, right? We have an x squared. If it was x, then we've solved for x. We haven't solved for x, we've solved for x squared. The inverse, or the opposite of squaring something, as we found out before in simplifying radicals, is taking the square root. If I take the square root of x, it cancels out the square. But if I do it to one side, I have to do it to both. So x, and I'm just going to flip it here so the x is on the left, is equal to the square root of 169. And then, this is where simplifying radicals comes in. I check and see if I can simplify this. 169 is a perfect square. It's 13. Excellent. So this is a whole number, and it works out to x is equal to 13. Perfect. So this is what it looks like if x is the hypotenuse. Let's try solving for when x is a leg. Okay, and these are examples that you can look at as you're doing your practice below. So this time, I've got a leg and a leg. I find my hypotenuse. I draw a diagonal line through here. This side is my hypotenuse. It's my longest side. It's directly across from the 90-degree angle. That's going to be the one that I have to use for c. Okay, so I have a squared plus b squared. My legs added together and squared are equal to c squared, my hypotenuse squared. So x squared plus, and then 48 squared is equal to c squared, 50 squared, just like that, okay? So the only difference is that here, the x went in for the hypotenuse for c, but here I'm using x as a leg, and I just include it just like I would any other one. X is a leg, so it goes in for one of the legs, and I square it. Now the solving for it's going to be a little bit different because x squared, we can't simplify that right now, but we can simplify 48 squared. That's 2304, and 50 squared is 2500. Now remember, our goal is to get the x by itself. that means that we need to sort. Any x's can stay here, and anything that's not an x goes to the other side. So I'm going to bring this over with the other numbers that don't have an x in it and subtract. 2, 3, 0, 4. And that means I bring down my x squared still on this side, and then when I'm done, I get 196 when I subtract. Okay, so the difference is here, I did not have to subtract to move it over because the x was already alone. Here, I have to move one of the numbers over. From here, it's going to be the same though, because to get rid of that square, I need to take the square root on both sides. So that cancels out, and x is equal to the square root of 196, and I can check in my calculator. Square root 196 should be 14, and it is. Excellent, we got a whole number. X is equal to 14. Okay, so I'm going to show you one more, and then I'd like you to try the examples. Let's try another one where x is a leg, okay? I'm going to actually skip the first one, and I'm going to scroll down, and I'm going to show you, well, I'll show you one more of both. How about that? Okay. Why don't you try this first one on your own? Pause the video until you're done, and then see how you did. Did you get x equals 10? If you did, you're right. So your first step should have been to figure out that, oh, this time x is going to be my c. My hypotenuse is x. So then I use my other two legs, and I do 8 squared plus 6 squared is equal to x squared. 8 squared simplifies to 64. And when you're doing that in your calculator, you can either do 8 and then there should be a square button on your calculator, or you can just do 8 times 8, same thing, right? Then plus 6 squared, which is 36, equals x squared. Just have to add these two together. Since x is already by itself, I don't have to worry about moving anything. When I add them together, I get 160, or excuse me, just 100, and that's equal to x. And my last step is going to be to take the square root on both sides. That cancels that out, and I get x, which I'm just going to move on this side to make it prettier, is equal to the square root of 100. And I can check in my calculator. Okay, let's see. Square root of 100 should be 10. Excellent. Whole number, you're good to go. X equals 10. That means that in order for this to be a right triangle, this side has to be 10 in order for it to work out to be a right triangle. Okay, last one. I'm going to show you this one. You may have already started it. This one's a little different. When I go across, first of all, my hypotenuse is 9, so C has to be 9, and my leg is going to be an x. So I have x squared for the leg. My other leg is 6, plus 6 squared is equal to my hypotenuse, which is a number, 9 squared. So I can simplify a little bit. I got 36 and 81. And remember that when we're doing the legs, since the x isn't by itself, we have to move it over, move the number over. So this 36 is going to come over here and get subtracted. And I get x squared is equal to 81 minus 36, which is 45. Okay, so now I have to take the square root to cancel that out, and I get x is equal to 45, or square root of 45. Then I use my handy-dandy calculator, and we're going to check. Second square root, 45. Ah, here's the thing. See how I get a decimal? This is why we learned how to simplify roots, because if it's a whole number, I can just write that down. But if I get a decimal, it means I need to simplify my radical using the method that I taught you before, or using a method that whatever method you're comfortable with. Okay, so I need to simplify this radical, which means I'm going to make a radical cake. All right, so I'm actually going to build my radical cake down here just to have a little extra space. I need to take 45, and I have to divide it by prime numbers to make a prime cake. Ends in a 5, so I know I can divide by 5. 45 divided by 5 is 9. Remember, I have to divide by prime numbers only. 9 divided by 3 is 3. And 3 divided by 3 is 1. Once I hit that 1, I'm done with my cake. And I take the numbers on the side, or going up the steps, and they're going to go underneath. So I have x is equal to, I just throw these all in, 5 times 3 times 3. If I have a pair, that pair can come out. So I have x is equal to, and then I'll draw my house, my square root. Remember, one pair, one comes out, okay? And then the 5 stays in. So my answer is simplified to this. This is also correct, but it's the difference between giving me like a simplified fraction and an unsimplified fraction. While this is correct, this is the simplified version, and you need to do that, okay? All right, so there are 4 more practice problems which you should be able to try. If you pause this video, I'll put down the answers and you can check your work. When you're done, there's 1 here and 3 on the back. So now that you've tried these on your own, you can see how we've worked through here. X was the hypotenuse, so it went here, and you had your leg and leg. You would have gotten the square root of 58, which you thought might be able to be simplified, but when you found that out, remember how we said that if there were 2 numbers underneath the radical and there were no pairs, it just stayed the same? So it's in its simplest form. The answer is x equals square root of 58. On the back, you did need to simplify that one. It was kind of a big one. Your final value, after you set up and solved, you would have gotten x is equal to the square root of 128, and then that simplifies to x is equal to 6 square roots 2. Remember, you can pause this if you need to take a closer look at any one of these or the steps. For the third, it worked out as a whole number, x equals 12. And for this one, you would have gotten x is equal to square root of 12, which simplifies to x square roots 2. So hopefully that is going, you're not having any issues with that. If you are, take a minute to review the steps that I've posted here, and if you have time, complete the practice. Thank you.